Okay, welcome to section 10.6. We're going to talk about one thing we talked about in the last lesson, which is tangents, and talk about another word which you haven't seen before, I don't think, is a secant. I don't know if we did this. I don't think we did this earlier in the right triangle, but the secant in trigonometry is a word that we use also, but it really doesn't have anything to do with these circles, just like tangent. The secant is actually the inverse of the cosine, so 1 over the cosine is the secant. But you're not going to have to worry about that in this lesson. What we're going to do is talk about what a secant is first, and then see some relationships between two secants, between two tangents, between a secant and a tangent. So let's start off showing you what a secant is. Remember, a tangent actually was a line that hit the circle just at one point, one and one only. Okay, didn't go through it, because if it went through it, it hit 2 points. It just kind of glanced it. So it just hit it at one point. Well, a secant, which I just said, actually goes through the circle. All right? And so if it goes through the circle, how many points is it going to hit on the circle? It's going to hit 2. So if it goes through the circle, it's going to hit at 2 points, and it's considered a line. Sometimes we consider just from one point on the circle to the other point on the circle. We still consider it a line, but there are times when we talk about the distance between one point on the circle and the other point on the circle. But for our definition, the secant is a line that hits a circle in 2 places, at 2 points. You could have it going all kinds of ways. Even if it went right through the center, that can still be considered a secant. It's not hitting it at 3 places. This is not considered on the circle. This right here is on the circle, and this point right here is on the circle. And again, it keeps going. Now again, there are times where you may want to just consider from one point on the circle to the other point on the circle. So even though we don't have arrows, and even though it doesn't go outside the circle like this, we can still consider that a secant as well. You could look at it as a diameter, you could look at it as a chord, but if it hits the circle here and it hits the circle here, you could also look at it as a secant. All right, let's look at our first relationship between two secants. We're going to have two secants that intersect each other in a circle, and we're going to see a little relationship. Okay, here's our first relationship between two secants. As you see, I've got secant, we'll call it AC, line AC, and line BD, which is also a secant. They intersect each other right here, and they form a couple angles. They actually form 4 angles here, but I marked 2 of them. I marked this acute one and this obtuse one. All right, here's the relationship. It's actually kind of interesting relationship. You've got some angles that are formed right here. So let's take a look at angle 1. If I wanted to find, let's see, let's change colors here. Back to yellow. Okay. If I wanted to find what angle 1 was, what I can do is I can take a look at the arc that angle 1 cuts off. So angle 1 cuts off this arc AD, but watch, if this is angle 1, so is this, because they're vertical angles, aren't they? So what I could do, and I'll just say this is angle 1 as well. We shouldn't really name 2 different angles the same name, but for the sake of making this a little easier, I'll call this angle 1 as well. So if this is angle 1, this is angle 1, and it cuts off this arc over here, arc BC. So let me try to sketch that. Try to keep on this as close as I can. Pretty good. Close enough. All right, so look at this. This arc, or this angle, cuts off arc AD, and this angle right here cuts off arc BC. So if I, yeah, that's good. Here's the relationship. It's a theorem, actually. It's a theorem. It's the first theorem of the lesson. It's 10.12. All right, I don't care that you know the numbers, but that's what the theorem is, and it's on page 727 if you want to look in the book. So let's take a look at what happens here. What we're going to do is we're going to take these 2 arcs, whatever the measure of those 2 arcs are. I'll tell you what, let's just stick some numbers in here just to make this a little easier for us. Let's say this is 30, and I don't know, let's say this is 70. That's good enough. Okay, I'm just making these up. I don't know how accurate that is, but we'll say this arc is 30 and this arc is 70. If you can find angle 1. Now remember, this is not a central angle, so this arc is not equal to this angle, and this arc right here is not equal to this angle. Remember, these 2 angles are equal to each other. That's 30 degrees, and that's a whole lot more than the 30 degrees. So there's no way that those two arcs are equal to these angles because it's not a central angle. It's not an inscribed angle. So there's really nothing that we know so far about these angles, about the relationships until now. Now what we can do is we can actually add the two arcs together, but that would be 100 degrees. That angle doesn't even look close to 100 degrees. Even though this might not be really accurate, I can tell that's not going to be 100 degrees. So what I'm going to do is I'm going to actually take half of it. So I'm going to add them together and then take half of it divided by 2. You're basically finding the average between the two arcs. That's really what you're doing. So if I wanted to find angle 1, it's going to be 1/2 the sum of the two arcs that it cuts off. So I'm going to say 30 degrees plus 70 degrees. And then that's actually pretty easy to do. So that's going to be 1/2 of 100. Just write it right here. Half of 100 is 50. So angle 1 right here, let's write it in here, is 50 degrees. So if that's 50 degrees, obviously that is 50 degrees as well. So that's how you can find the angle inside here. That's pretty interesting. So if I know the two arcs, I just take the average of the two arcs. How do you take the average of two numbers? You add them up and you divide it by 2. That's exactly what we've done right here. You could do the same thing with angle 2. All right? How would I find? I'll tell you what, let's write it in here instead of putting the 2. I could actually figure out what angle 2 is, because if this is 50, this is its supplement. See how they make the straight line right here? Straight angle. So if this is 50, this has to be 130. So it's 180 minus 50, which is 130. And of course, this would be 130 as well. Oh, you know what? Actually, with this amount of information, I don't believe we're able to find these two arcs. So I was going to go with that, but we're not going to be able to do that in this situation. If they told you one of the arcs, you could find the other one. In fact, let's do that. Let's see. I don't know if it's going to work out right. Let me pause this, do a little bit of math, and see if I can stick a number in here that works. All right, I'm flying by the seat of my pants here, so let's give this a shot. Let's say this is 80 degrees right here, and I wanted to find this arc, DC. It's a minor arc, okay, because it's less than 180 degrees, because if you go like this, that's going to be shorter than the diameter. So it's a minor arc, so I can just say arc DC. Let's just make it easy. Let's just call it X, if that's okay with you. So we'll call this arc X. So how in the world would I find X? Well, remember, this angle is equal to the average, or half the sum of the two arcs. So the angle, which I know this time, is a little different than what I knew on the yellow stuff. So the angle is equal to 1/2 the sum of the two arcs. And so if I add up 80 and X, it's not 80X, it's the sum, it's X plus 80. Or you could put 80 plus X if you wanted to, I guess. Alright, so how would we solve for this? Well, let's just solve for X. Let's get rid of that half. We multiply both sides by 2. So I'll multiply this by 2 to get rid of the half. That's 260. And that's equal to X plus 80. We subtract 80 from both sides. And 260 minus 80 is 160. So X is 160. So that angle right there is 160 degrees. Right? So that's kind of an example. Let's do an example that they give us in the book instead of me making up my own example here. Alright, this example is pretty straightforward. It's just like what we talked about before. You just have to find this angle that's made by the intersection of the two secants. And it's there's really nothing tricky about this one. Remember, this angle is half the sum of the two arcs that it cuts off. So this angle cuts off this arc right here, the 130, and this angle right here cuts off this 84 degree arc, this RS right here. So I'm just going to say X equals 1/2. Sometimes people don't like to put the 1/2. Some people like to just say over 2. I don't know, it's easier for some. And then what do? You just add up the two arcs that angle cuts off. So it's 130 plus 84. And 130 plus 84 is 214. So it's 214 divided by 2. Divide that by 2, and that's 107. So that angle X right there, is 107 degrees. All right? Not too bad. Let's do another example. Okay, this is example B. Let's put that right there. And look what we're trying to do here. We're trying to find X. It kind of looks like what we just did. but with a little bit of a twist, because watch this. If I wanted to find this x directly, I would have to know this arc, BD, and I would have to know this arc, AC. I don't know either one of them, so I can't find this directly. But what I can do is find this angle right here. It's not named, but I can find this one, and of course I would use this angle right here as well. Because I do know the two arcs at that angle, that unknown angle, cuts off. I know this is 75, and I know this is 143. So I can actually find this angle right here. But you're probably saying, well, what's the big deal? Why do I need to find that angle? I'm trying to find this one right here. Why would I want to find the one next to it? Well, if you look at it carefully, it makes a straight angle, just like we talked about a few minutes ago. It makes a straight angle. So if I can find this one right here, this blank one, I can just take that answer away from 180, and then I can get x. All right, so let's go ahead and do that. Let's find this blank one. We'll call it y. Okay, just to make it a little easier for us. So let's solve for angle y. So angle y is half the sum of the two arcs that it cuts off. So let's put that right here. So half the sum, let's add up the two arcs and divide that by 2. So if I added them up, I get 218. And then if I divide that by 2, that's 109. So y is 109. That's not my answer, though. That's this angle right here. This mess. Let's put the actual number in here. This is 109. And then if I find, if I know this angle right here, I can find this one right next to it, adjacent to it, because they're supplementary. They add up to be a straight line, straight angle. So I know those are add up to 180. So I just take 109 away from 180. So it's 180 minus 109, and that's what? 71 degrees. So angle X is 71 degrees, and that's what they're asking for right there. Okay, here's the third example, example C, and let's see what we have to do here. They give you the angle that's created by those two secants in here, all right? Because we kind of remember that one I made up, and I kind of messed up a little bit. They give you that angle. They give you one of the arcs that angle cuts off, and they're asking for the other arc that it cuts off. Remember, these two angles are equal to each other, and so this is the arc that this angle cuts off, and this is the arc that angle cuts off. So if you remember, what's equal to what? Well, the angle, which is 110, is equal to this half, the sum of the two arcs. So there's the half and the sum of the two arcs. So I have to add the two arcs together. And that would be x plus 97. Remember, I stuck a 1/2 out in there in front. It's the same way. I just want to show you like two different looks to it. It's not really two different ways. It's just two different ways that it could look. Okay. Anyway, so what do we do here? We multiply both sides by 2. So if I multiply this side by 2, I get 220, and that's x plus 97. Subtract the 97. This should be old hat for you. At this point, if we subtract 97, I get 123, I believe that is. So x is 123, and that's what this arc is, 123 degrees. There you go. Simple as that. Let's move on to another type. So now we talked about two tangents. Now we're going to talk about a tangent and a secant. Okay, here's what the theorem says. This is a new theorem. It's the next one, 10.13, 10.13. And here we have a secant. This one right here is a secant. And I'll tell you what, let's put some letters in here. I should have done that before I started talking. Put an A here, put a C here, and put a B right here. That means that's where it hits right there. Okay, that makes it a little bit easier. So what we have here is a secant, and we have a tangent. And the secant actually hits the tangent at the point of tangency. It's very important right here. Okay, so the secant, where it hits on the circle over here, is where the tangent hits. So they intersect each other right on the circle, just at one point right there. So I've got a secant and a tangent. Well, here is what we know about a secant and a tangent. The angle that it makes right here, so I picked this angle, angle 1. Actually, it makes two angles. It makes this angle 1, and it makes this angle right here. We'll call that angle 2 in a second, but let's just deal with angle 1. Let's see what arc it cuts off. So the secant comes to here, hits at B, and it's at A. So on this side of it, it cuts off arc BA. Oops, let's try this again. I know I'm not going to be perfect. That's a long way to go around. Let's see. Well, that's not too bad. Look at that. A little messed up here. You get the idea. That arc right there, BA, that blue arc right there, the angle, and this is what's nice and easy about this, the angle is exactly half of the arc. That's it. You don't have to add anything up. Just figure out what the arc is, and the angle is half the arc. So let's say, I don't know, 140 degrees, let's say. All right, so let's say this arc is 140 degrees. This angle 1, so angle 1 would be half of the arc that it cuts off, 140 degrees. So that would be 70 degrees. All right. Now, if I wanted to do this, different color here, let's talk about angle 2, where it goes from the secant to the tangent. So we'll talk about angle 2. Now, I should know what angle 2 is, because if I know angle 1 now, angle 1 is 70 degrees, then this is 180 minus 70, which is 110. So this angle right here is 110. Now remember, the angle is half of the arc, or you could say the arc, I'm not going to try to draw around this one, it's too large. So this arc BCA right here is going to be twice as big as the angle. So if this angle is 110, this arc is twice 110, which is 220. So that means from A through B through C all the way back to A again around the whole circle, you know it should be 360. Let's see if it works out. 140 and 220, yep, if I add them up, I get 360, and so it works very well. So what happens again? We got a secant and a tangent. The angle that it forms is half of the arc. Or you could look at it the other way and say the arc is twice as big as the angle. Okay, here's the last thing that we're going to do. So far, all the intersections have been either inside the circle. Remember, we had the two secants, they intersected inside the circle. And then we had a secant and a tangent that intersected on the circle itself. This time what we're going to do is we're going to have two things that intersect outside the circle. So here's three different situations. That's why I have three different pictures here. And I'll just draw it for you so you can see what I'm doing. This time I've got two secants. Okay, they hit the circle at two places, but look where it intersects. It intersects outside of the circle. So that's a pretty big difference compared to what we've had before. And here is the relationship between that. Cuts off these two arcs right here. And I'll just cuts off this arc. I'm not going to label them. We'll just do this. Tell you what we'll do though. Just to make it a little easier for you, we'll stick some numbers in here. We'll say that's a 20 degree arc. We're saying that arc right there is 20 degrees. Okay, well, let's put that 20 right here. Okay, so that arc is 20 degrees. And let's arc is, I don't know, let's say 80 degrees. Just make the numbers easy for us. So here's the situation. If I know the two arcs that these two secants cut off. Now remember, these intersect outside the circle. The other two secants intersected inside the circle. So how did we find it? We found the average. We added them up and divided them by 2. This situation is a little different. We're going to find this arc right, or this angle right here. We'll call it angle A. If I want to find angle A, I'm not going to add the two arcs together. I'm actually going to subtract the two arcs and then take half of it. So I'm going to subtract them, take the bigger one minus the smaller one, and then I'm going to divide it by 2. That's how you find the angle that's on the outside of the circle, the exterior angle. Okay, so if these two secants intersect outside the circle, I'm going to subtract and divide by 2. Remember, when they intersected inside the circle, we added them and divided by 2. So this would be 60 divided by 2, which is 30 degrees. And that's what this angle A would be. It would be 30 degrees. Time I've got a secant and I have a tangent, but it still cuts off a couple arcs. This cuts off this arc, which is 100 degrees, and it also cuts off this arc right here, which is 160 degrees. The math is exactly the same. That's why I put all three of them on the same page here. So if I wanted to find this angle B, I take the two arcs that it cuts off, which is 160 and 100, and I do the exact same math. So I go 160 minus 100, again minus, and so what's that? 60 over 2, and that would be 30. I don't know why I got the same answer. I'm just making these numbers up. But this would also be 30 degrees. There was no rhyme or reason for that. Okay, pretty simple. Let's do one more. I had two secants. I had a secant and a tangent. What do you think this is going to be? This is going to be two tangents. Okay, here we have two tangents. Now look, they only give you one arc. They give you this arc from here to here. I'm not going to put letters in here. A little squiggly, but that's okay. They give you this arc as 100. So how do I find the two arcs? They only give you one. Well, watch. From here to here is 100. What's the other arc? The other arc is from here to here. It's the rest of the circle. So how do I find the rest of the circle? I just go 360 minus 100, and that would be 260. So this arc right here would be 260. How do I find this angle C? I find the angle C by taking the difference of the two arcs. So that'd be 260 minus 100. Okay, and what's that? 100, oops, had it divided by 2. I was getting ahead of myself. So that'd be 160 divided by 2. 160 divided by 2 is 80. It's not a very accurate picture right here, but that's okay. The math still works. All right, so that's how you find these exterior angles. And that is it. So that's all the examples we'll do. Excuse me. That's all the examples we'll do with this. Man, if I could talk right. You can look in the book if there's a couple more examples that you want to do, but that pretty much sums it up. All right, enjoy this lesson.